no such cell as we know. So last time in the chapter, and we said that so far, chapter 2 was about the first thing that I'm writing, why we need how it's kind of easy to get and the famous distribution that is transformation on transformation. Sorry. And then basically the conditional integration. The theme was about against number function moments, characteristic functions, and integral transformation. As we mentioned last time, chapter 4 will be a generalization of chapter 3, chapter 2, sorry, where basically we will discuss two arguments. We have made more than one value in one value. Our focus in this class will be two values. And we will talk about why we need to have values, what are how to start, and then we talk also about the relationship between independence, the concept of independence. Chapter 5 will be similar to chapter 3, however, actually got two values. So joint moments, joint simple moments, joint characteristic functions, almost the same as what we have done for chapter 3, so to see then we get the for two values. So basically this is the chapter with content on so sections. We'll start with the definition why we need these two random variables on. So, as I mentioned in the class, in many cases you need to describe certain phenomena by more than one by more than one for example, the weather doesn't only depend on the temperature, doesn't depend on the pressure. So, if you want to decide what to study, what will be our forecast, what will be the temperature in 1 day, or whatever, then you need to talk about several values. One of them describes the other one, the other one. So, in general, practical scenarios or practical random practical scenarios where you need to do really, I would say, measurement, you need to have more than one value to study your phenomena. Another example, for example, here, where there is a shooter who basically tries to shoot a certain goal. Now, every shooter will have basically, when he shoots, he will hit a certain point within, for example, this. If you are a good shooter, you will hit something very close. If you are a bad shooter, you will hit very far from the goal, right? However, every time you shoot, you will hit something. Now, how to describe the place where it hits? One random variable on the x-axis is not enough. You need to have something that describes a point in a plane. In this case, you need to have an xy coordinate, right? So in order to describe where every time you shoot, your bullet will land, you need to have an x-axis coordinate and a y-axis coordinate, right? So you need to have two points. Every time you shoot, the outcome of the experiment will be a point in a plane which is described by two parameters, the x coordinate and the y coordinate. Okay, now clearly, every time you shoot, you never get the same place that you did before, right? Otherwise, the point of this to happen is zero, right? You get exactly the same place. So every time you shoot, you will get a different number. As I mentioned, if you are a good shooter, then basically the probability, most probability will be focused very close to the target. If there is another shooter who is a bad shooter, like a lousy one, then basically the probability will be distributed more towards probably be far away, and sometimes he will miss, he will hit close to the target, it will be random. Come on. So now, first of all, we need two random variables to describe this thing, which is the location of the shooting or the bullet. And we need to know how are these two locations, or how to describe these two random variables at the same time. Okay. Similarly, you can think about it as I mentioned in terms of temperature. The weather depends on the temperature and the pressure. They are related. So, for example, sometimes the temperature is low, however, sorry, the temperature and humidity. Temperature is low, however, humidity is high. Tells you whether it's bad, right? So even if you get a temperature 30 with a high humidity of 80, still the weather is not nice. So if you would like to characterize the weather whether it's a nice or not nice, or in good in 4 or 5 categories, then in this case, temperature only is not enough. You need to have temperature and, for example, humidity, temperature and pressure, many things. So the point of multiple random variables or two random variables in our class. So in our class, we focus mainly on two random variables, but the concept generalizes to more than that. So in this case, if I have an experiment, so the experiment is anything, as I mentioned, measuring the weather or whatever. So you have a sample space. This is the sample space. Sample space has elements, right? Every time you run that, you need to get an element. So now this in single random variable, when we had single random variable, what did we do? A single random variable, every S1 goes to what is now? To X1. S2 goes to X2, right? So basically, there is a mapping between the sample space and the random variables. In multiple random variables, for example, in two random variables, X and Y, let's say. Then in this case, S1 will be mapped not into a specific value in the real line. No, it will be mapped into an order pair, X1 and X and Y1. So basically, S1 here goes into, instead of mapping onto only X, it will be mapped into a point. Okay, which is, so this is for this S2. So for example, S1 will be mapped into, what is this one? This one. So basically, S1 here is mapped into this point, right? Which is X1 and Y1. While S2 is not mapped into a real number that is in X only. No, it's mapped into another order pair. Yeah, this is S2. So this is X2 and S2. We have S1. Am I confused? Straight. S2 goes into this point and this point. Sorry. S1 goes into this and this. S2 goes into this. Exactly. So like basically ignore this. Vanish. S1, we just use another one. S1 goes into this, so this is X1, and this is Y1. So S1 is basically this point. واضح شباب؟ هذه في خطأ في الصورة معلش. So this is X1 and Y1. While S2 goes into this point, so this will be X2. The map or the mapping of S2 into the X-axis, and this will be the image in the Y-axis. And this will be basically S2, which is X2 and Y2. Okay, so now the outcome of the mapping will be what? Yes. So the outcome of the mapping, so the sample space is not mapped into the real line anymore. The range of the sample space, so the domain is sample space, the range is in the single random variable was the real line. It could be a part of the real line, it could be the whole line, the real line, it could be only the set of integers if it is discrete. Now here, the sample space again is the domain. However, the range is not anymore the real line, it's the plane, the two-dimensional plane. Okay, the two-dimensional plane. It could be only a discrete part of the two-dimensional plane, if it's discrete, if X and Y are discrete, or it could be only a part of the two-dimensional plane, or it could be the whole two-dimensional. What?
So X and Y are two sample spaces in a bigger sample space.
No, X and Y are the coordinates of the image of S1. For example, X1 is Y1 is the order pair that is the image of S1. Outcome of X1. يعني نرجع للshooting. When you shoot once, this is one output. Now, this outcome is translated into the two-dimensional plane in a location, specific location. Okay? This is
when you sample space, this is described by
two basically random values. So now when you shoot again, you get another sample space outcome. Every time you shoot is as if you are running an experiment, right? So you get one outcome. Now when you get another outcome, it might be here. What is this? This is x. This is described by the x coordinate. So this will be x2, y2, and this will be x1, y1. So now the result for us as EFT 15 students, we have two random variables, x1, so the x and y, describing the same thing. Well, now how these x and y are described together, we need to define what we call joint PDF, joint probability distribution, joint PDF, joint probability distribution. However, the main idea is here is to understand why we need two random variables, or why we need three random variables. As I mentioned, in practice, in real scenarios, one random variable may not be enough to describe your randomness, the behavior of the experiment at hand. Okay? Now? This is just, it's basically two-dimensional data. Here, the example, that's a good question. The example here is only for the virtual part of the two-dimensional data. Two-dimensional data is R squared, anything between minus infinity to infinity x, minus infinity to infinity y. So it's the full two-dimensional data. This is just an example. Okay? Any question? Where two-dimensional or the two random variables exist, why they exist, and so now let's see. Now we call the two random variables or more a vector of random variables. Vector of random variables. So if I have two random variables, x, so basically a vector of random variables is random vector. You can answer me. A random variable x is a mapping from S to R. A random variable y is another mapping from S to I to R. Now the random vector xy, x is a real number in general. X can take any real number, y can take any real number, is a mapping from S to R squared, which is the two-dimensional plane. R cannot a real line. R is the real line in the y-axis. R squared is the two-dimensional. So basically, every item in S here is mapped into an ordered pair rather than a number. The single random variable, every outcome is mapped into a number. Here, every outcome is mapped into an ordered pair. Am I sure? So let's have, for example, another example. Here is the tossing two coins. Tossing two coins. How many outcomes will be? Right? So tossing two coins. What are the possible outcomes? Oh, head, tail, head, and tail, right? And the probability of every one of these is 1/4. They are equally likely because it's both coins are tails. There's no reason to believe that it will give you tails more than heads or coins. Now I can define the random variable x, one random variable, as the number of heads. Let's say 1 after 2. And you end up with number of heads so x can take the value of 2 when you have 2 heads. It can take the value of 1, right? When it is tail, head, tail, and it can take the value of 0. And you know the distribution of x. What was the distribution of x? كيف شكل distribution حق x? Fx of x. What was it? You have 0, right? And you have 1, and you have 2. Right? What was the probability of 0? 1 over 1. What was the probability of 1? And the probability of 2 is 1. This is x. Now I can define another random variable. I can define another random variable, which indicates similarity between the outcomes of the head of the two points. For example, y is defined as if I have similar outcomes, head, I give it 1. If I have similar outcomes, I give it 1. Tail, or head, this is 1. This y describes the similarity. However, if I have different outcomes, I give it -1. Different outcome, tail, head, I give it also -1. So this is now clearly y is different than x. It describes different behavior of crossing the two points. الأول كان يعطيني how many hits. الثاني يعطيني when were there the two crosses outcomes similar or it's a different way. Now how can we write y? خلينا نقول probability of everyone. So what is the distribution of y? Yeah, the values that y takes clearly are only two values, 1 or -1. But what is the probability of -1? Because it happens only twice out of 4 outcomes, so it's half, and the other probability is. So you can see clearly that x and y, so this is fy, are totally different than y. They have totally different values, totally different distributions. However, they are related. Okay. نشوف الآن what is the probability that x, now I can see, now I can join them together. What is the probability that x, خلينا ناخذها بطريقة. This is the outcome, this is the mapping between for x alone, for y alone. What about for everyone, for together? Yeah, let us have a table with s and x and y. The value together. So now, if s is head and head, what do I get? Head, so. شباب x equal كم لما يكون head 2 and y is 1. What about head tail? 1 and -1. They are this similar. What about tail head? 1 and also -. What about tail? 0 heads and they are similar, 1. And you can see that the probability of every one of these is the probability of 2, 1. 1/4. What about the probability of these two? Together, they are 1/2, right? So basically the probability of this is, what about the probability of tail? 1/2. So now you can see that the x and y together, they can take how many dots, how many points in the two-dimensional plane? 3 different points. Everyone, this has a weight or it happens with a probability of 1/4. This point happens with a probability of 1/2. This happens with a probability of 1/2. And you can see that they are related. In similarity is related to whether the number of heads is large or not. For example, you have 2 heads, they are similar, and 0 heads, they are also similar. Right. Now let's talk about the probability that x equals 7.
This is the next one. عند الاكس الواي بلين نصل نحط 4 نقط.
4 نقاط.
مثلا
لا ليش 4؟ هي كم؟
4.
بس هذه نفسها صح؟ They are the same point. Repeated twice عشان كده اعطيناها البروبابيلتي حق هذه probability 1/4. So together they are 1. طبعا.
عند الفاريبل واي عندها ابديت النمبر اوف هيدز بيكون نفس
number of tails. You can define z to be number of tails. Z number of tails will be the opposite of
بس بيكون نفس البروبابيلتي
نفس البروبابيلتي حق الاكس. ده قلنا ترى definition of value variable is your choice. انت you define it. Then كلام chapter 2. You define the value variable that suits you, that makes your life easy, that basically helps you in describing the الفينومينا. تمام؟ تفضل.
X of Y random variable, because you put the probability as a amplitude of the delta. What about
هنتكلم عن طبعا زي ما قلنا احنا الان only try to introduce the concept لكن هنتكلم عن how to describe it using the joint PDF density. لكن الفكره اهم شيء الان if you don't get the idea راح نتكلم بعدين معك تصير ضيع. You need to understand the idea why we do this And what is this mapping? So الآن خلينا نتكلم على الjoint probability. Since we have two random variables, x and y, we can have the joint probability. So this is the joint probability. Of x and y. So this is and. هذه كله and. نتكلم عن joint, this is and. So what is the probability that x equal to and y equal to? X equal to, sorry, and y equal 1. It's the probability of the corresponding events, صح? Points هنا أو events ممكن ترجع هنا. When does x equal to and y equal to 1, 2? When you have events, صح ولا لا? So this is the probability of points. 0.24. While the probability of the probability of x equal 1 and y 1. When does it happen? Can x be 1 معناها y head مين ايش الثاني ايش؟ tail. Can x be 1 and at the same time they are similar? So this is the probability of head tail head and head tail tail. The probability of x equal 1 is this. The corresponding event to x equal 1 is head tail tail. The corresponding event to y equal 1 is head and tail tail. What is the intersection between them? No common factor, 5. So the probability of 5 is. This is an impossible event. The point having does not exist in the two-dimensional plane. Or it has a 0. But let's talk about different events. X less than 1 and y larger than 0. When does x less than 1 happen? When you have two tails, right? When you have 0. So you have two tails here. This is the corresponding event. When does y is larger than 0? They are similar. So basically when you have head and tail. What is the intersection between them? Is the tail, which is 0.25. Okay, and you can describe different probabilities and try to find it. The point is you need to be able to describe two random variables out of the sample space. And then you need to be able to find the joint probabilities using the corresponding events for x and y, and then finding the intersection to get the probability. And you need to be able to find the mapping table with the probabilities. So this is the probability of x, y. Okay? Later on, when we talk about joint probability distribution, we will be able to plot what we call joint PDF. خلينا نرسم الآن بس على السريع عشان لكن we will not assume that you know it. Let's also see dimensional things. This is a good thing. This is x and this is y. So this will be what we call f, x, y. هنتكلم عنه بعدين. Assume that you know it. What does this mean? These are the pulses, the points that can happen. What are the points? 2 and 1, right? So this is 2, 1. So this is 1. And 1 and minus 1. 1 and minus 1. And 0 and 1. This is 0 and 1. So this is. So these are the three values that x and y can take. Imagine that a two-dimensional PDF will be fingers pointing in the z direction. The probability of this point is coming 1/4. This point, another 1.2. بينما هذا البوينت كم؟ finger طويل. Okay. This is basically roughly speaking. So basically this will be like half. بينما هذول الاثنين خلاص. 1/4. بسمع. We'll come to it later لما نتكلم عن joint PDF and CDF. Now let's talk about the joint CDF أول شيء. دائما ال CDF أسهل في definition. لكن after that we talk more about the PDF because it's easier to use. Now joint commutative CDF or commutative distribution function. This is the joint CDF. So whenever we say in the features joint CDF means the joint related distribution function of two line variables. تذكروا ال cumulative distribution function, the only what was it? It was defined as fx of x for single random variable. So this is single random variable. How did we define it? Well, the probability that x is less than or equal specific number. So this here, the subscript x denotes a random variable, and the small x is a dummy variable, is a number. Okay, and it was equal to the probability that x is less than that number. Now remember, this defines how the probability increases from 0 to 1. When x is minus infinity up to x goes to infinity. It goes increasing, right? It's an increasing function. How does it increase? Does it increase suddenly at 0%, or does it increase gradually? This describes how the probability accumulates from 0 to 1. Right? And when you have two-dimensional random variables or two random variables, we can define the event A on x such that x is this time or equal to this time. And B is another event on y, where the event B is y this time is specific number. Then you can define the joint probability that x is this time specific x and y is this time specific number y, which is the intersection between A and B. Okay. Now the joint CDF probability distribution function is equal to the probability that x is less than x and y is less than 1. And it's defined as this. F, x, y. So these are random variables. These are the random variables. بينما small x to small y is what? Are what? Dummy variables. And the way it is defined for the specific x, small x and small y, this is a number, which is the probability that the random variable x is this time this number x, and at the same time the random variable y is this time. Let's have it pictorial and see. Now, if I have this is S, and how we said S, every item here, every element, every outcome of the experiment is mapped into what? Order pair in the plane, right? Every item, every element is mapped into order pair, x1 and y1. S2 is mapped into x2 and y2, and so on. Now, you need to find, for example, A here. A is an event n on x. A is what? A means all the variables, also the values that x is this time specific number. So this is where A is. Right? Everything that x with values x this time small x. So in the real line, this is only part of the real line, right? However, in the two-dimensional plane, it's a subplane. Right? It's a plane that takes from here all the way to the left. So basically, x this time x is everything here. Everything to the left. Everything to the left. Right? بينما in the y, the event here, B, is defined as y is this line specific number. When does y is this line specific number? When does y is this line specific number? Where is y? This is y. So y less than specific number y is this. Okay. Now, this is if only random variable y is there. So it's only the values that y takes in the real line, that is this time, the number y. But anyway, in the two-dimensional plane, it becomes a whole section. Right? A whole subplane. Now, the probability that x is this than x and y is this than y is what we call intersection between these two. What are these? It's the area here, where x is less than x and y is less than y. It's the intersection between the plane, the green plane, and the red plane. Okay? Now, if we find this probability, we find the probability of x is less than specific x and y is less than specific. It's only one value in the CDF. Now, changing x and y will change the location of these planes, the intersection of them, and will change the probability that x and y, sorry, x is less than x and y is less than x. So sliding x and y, changing the location of x and y, will give you different probabilities, which will make this a function. It's a function, it's a two-dimensional. It's a function of x and y. Okay, Shwan?
ايش المقابل؟ الانسان سبيشل كذا ليش في شيء فوق برا وفي شيء جوا؟
اي فاهم.
في هذا شيء جوا الاكس لسان اكس واي وفي شيء برا
هذا
وهذا بس ارقام.
هذه الان خلينا نشرح الاخضر هذا كله هذا what x is less than x بينما الازرق هذا is y less than. The intersection between them is x less than x and y less than. تمام؟ Other question. Similarly, now if we have three random values, although as I mentioned in this class, we'll not talk much about three random values or more. However, it's the same concept. It's the probability that x less than x, the CDF of x1, x2, x3. These are random variables of the dummy variables x2, x3, x1. Is the probability that x is less than x1 and x2 is less than x2 and x3 is less than x.
So that means x and y will form a intersection.
طبعا هي انت two dimensional plane. Two dimensional plane they are interact. هنتكلم بعدين عن حاجه اسمها independence. where basically we will يعني when x and y are independent basically ما معاهم. There will be no intersection between x. لكن بعدين خلينا أول شيء نمهد الأشياء الأساسية. Right, let's have an example. Now, we have these two random values, x and y. So here the two random values are defined as follows. الجوينت أنا أعطيك الآن ما قلت لك إيش الإكسبيرمنت ولا قلت لك إيش الأوتكم إيش السامبل سبيس ولا أنت تعرف إيش السيت أوف أوتكم. This is not relevant. What you need to know is the joint probabilities. X can take values 1, 2, 3, and y can take values 1 and 2 and 3 on. Okay? So x can take 3 values, y can take 2 values. And the probability are given, the joint probabilities. X equal 1 and y equal 1 is 0.2. X equal 2 and y equal 1 is 0.3. X equal 3 and y equal 3 is 0.5. And the rest of points, the points in the two-dimensional plane are impossible. We cannot have. So basically we have here how many ordered pairs that are possible? 3 ordered pairs. 1, 1, 2, 1, and 3. If you look at x alone, what are 1, 2, and 3? If you are looking at y alone, you have only 2 values. So now we have this joint probability. Now let's talk about شكل طبعا يعني خلينا نتكلم على الديستريبيوشن او البي دي اف. لسه ما عرفناها رسمي لكن at least it's easier to visualize. Now what is these probabilities? If I look at the two-dimensional plane, this is x and this is y. Then how many points you have that have non-zero probability? 3 points. اللي هي 1 1 and 2, 1, right? And 3, 3. This is the third one. And you can see that the probability of 1, 1 is 0.2. So it's a finger in the point with length 0.2. The probability of 2, 1 is 0.3. The probability of 3, 3 is 0.5, right? Have at least, this is a visualization of the total probability of 1. How is it distributed? Am I getting? X and Y, the two-dimensional plane. So this gives you how is this total probability of 1 distributed among all the values of X and Y, the two-dimensional plane. You can see that most of the probability happens at 3, 3, and lower probabilities happen at 2, 1, and 1, 1. And the rest are impossible. You can't have. Right? Now, assume that I would like to find the CDF of X and Y, which is the joint CDF, at 2 and 1.3. So at X equal 2 and 1. What does this mean? By definition, always go to the definition. ايش الديفينيشن حق الجوينت distribution? It's the probability that X is less than 2, less than or equal to 2, and Y is less than or equal to 1. The value of the CDF at any two numbers, X and Y, is given by this. Just plug the two numbers. Now the question is, what is the probability that X is less than or equal to 2, and at the same time, Y is less than or equal to 2? How to find this probability? We go to the events. What is the corresponding event? X is less than or equal to 2? 2 or 1. So basically, this means that this is the probability that X is. So basically, in X, you have X equal 2 or 1, right? What is the corresponding event of Y? Y equal 1 on. So you have putting this together gives you the ordered pairs. What are the ordered pairs? 2 and 1 and 1 and 1. This is the way we found this. 2 and 1 and 1. Okay? Well, yes. Now, what is the probability of 1 and 1 and, this is and, 2 and 1? Sorry, not there. I'm sorry. What is the probability of these two events? In this case, we are talking about this is the and here. Now we are talking about the probability of this set together. It's the probability of the first. الست هذه عبارة عن union of the two sets, right? It's the probability of this plus the probability of this because they are mutually exclusive. So this is the probability of 1, 1, and this is the probability of 1, 3. Sorry, 2, 2. واضح شباب؟ This is 1, 1. This is 1, 2. So the probability is the CDF at these 2 points at this order pair value is 0.1. At least this is the way you calculate a CDF. So in order to plot the CDF, you need to find this for all values. Now, before we do this, let's talk about what we call marginal probability. مهم جدا انه when we talk about joint probability, we talk about marginal. Joint, when we discuss probabilities that concern X and Y, an event in X and an event in Y. Now, the marginal is when we talk about only X alone or Y alone. So now, if I want to talk about Y, Y can take how many values? 2 values, 1 and 2. So what is the probability of Y equal 1? It doesn't matter what X is. Y equal 1, and هذا المهتم فيه الآن. عشان كده نسميه marginal probability. It's related to only part of the whole story. It's only marginal. We'll talk about is Y. So when I am interested in probability of Y equal 1, what is the corresponding event here? Y equal 1, X equal N. صح؟ X equal N. It doesn't matter what X. أنا ما قلت ما طلبت منك شيء عن X. أنا ما أعرف X. أنا أبغى probability that Y equal 1. So X is marginalized. فكده نسميها marginal probability. X نعم
ايش يعني marginalized؟
marginalized يعني خمسين. When I marginalize person يعني مو معقول. Okay, so it's a total probability. Exactly, it's basically the probability of y. أول شيء there are different ways to calculate it. واحدة منهم اللي أنت قلتها total probability. The other way, which is the direct way, is to go and find the corresponding events. That is, you go and find the corresponding events. It makes it easier for you. When does y equal 1? When y equal 1, when x equal 1, and y equal 1 when x equal 2. So basically we have 1, 1 and 2, 1. What is the probability of this to happen? 1, 1 and 2, 1 is basically 0.2 equals to 0.2 plus 0.3, which is 0.3. Huh? What about probability y equal 3? When does y equal 3? Only one time when x equal 3. So basically this is the probability of this event, which is 0.3. بينما الآن لما if I look at x only, so I marginalize y. أفنش y كأنها y مش موجودة. I ask myself what is the probability that x equal 1? When I ask من المعلومات اللي عندي when does x equal 1? Only here. صح? So this is the probability of 1, 1, which is 0.2. Probability that x equal 2. When does x equal 2 in the given information? When y equal 1 only. So this is 0.3. And when does x equal 3? When y equals 3, which is 0.3. Well, so the marginal probability comes from the word marginalize the other variable. If I want the marginal probability of y, I marginalize x. If I want the marginal probability of x, I marginalize y. I average over it. So now you can think of, you see, for example, the PDF of x كيف شكلها يا شباب؟ كيف شكل ال PDF of x? You have 1, 2, and 3, and you have at 1 is what? 0.2, 0.3, and 0.5. 0.3, 0.2. بينما ال y, how does it look like? PDF of y? It's 1 and 3. 0.5 and 0.5. Okay. Now this is the marginal PDF of x. This is the marginal PDF of y, and this is the joint PDF of x. We combine them together. Okay. واضح شباب؟ Now let's have examples on the marginal CDF mode. So if I ask you what is the CDF of x and y at 0 and 5. Yes, and with 0 and 2. Let me spread out. For example, this way. Think about it. Yeah. So think logically. How do we find this? We go back to the definition, right? The joint CDF always go back to the definition. And then from the definition, go to the corresponding event. And then find the probability. That clear. Otherwise, you make mistakes. If you jump one of these steps without being skillful, you might make mistakes. To avoid any problems, always go back to the probability, the definition, and then translate into events, and then you'll find the probability. Send me the attendance while you're doing it, please. Zero? I am sure. 0.50. Adults? 0? I am sure. What is this? Then go back to the probability. What is this? Probability that x is less than or equal to 0 and y is less than or equal to 5. Can x الآن السؤال what is the corresponding event؟ خلينا ناخذ واحدة واحدة. What is the corresponding event to x less than or equal to 0? Do you have x equal to 0 here or less than or equal to 0? So this is 5. The corresponding event. بينما y equal less than or equal to 2 ايش ال corresponding event؟ y equal 1. So it's possible in the y-axis, but it's impossible in the x-axis. So this is equal to the probability that of phi intersect y equal 1. صح? Which is C. So that at least you know how to do it. Yeah? لأن هذا and. These are AND together at the same time. X is like دائما نتكلم على joint CDF تكلمنا احنا قلنا this is AND. AND is intersection. تمام؟ طيب another example. Quick. F X and Y evaluated at angle 3, 2 and 1. يلا. Again, go to the probability, the definition, and then find the corresponding event, and then find the probability. ماشي شباب. 0.5 يعني. نشوف. This is probability that x is less than or equal to 2 and y less than or equal to 1, right? What is the corresponding event in x less than or equal to 2? It can take 2, 1 or 2. بينما the corresponding event هنا y equal 1 or 2. So basically this is the probability that you have يعني خلينا نقول x equal 1 and 2 intersect with y equal 1. When does so basically this is the probability that of the ordered pairs 1 1 1 1, right? And 2 which is 10. 1 1 is 0.2 plus 0.10 3 with 1.
الأول كانت AND بعدين صارت OR.
Yeah. شوف لما نتكلم عن x alone and y alone this is AND. Now we found the corresponding order pairs. So this is خلينا نقول نسميها set. This is the set of these two order pairs. Now this is the probability of a set. ايش probability of a set? This is the union of the probability of every item. صح؟
إذا كانت تعرف بداية.
إيه يعني إذا عندي أنا set، الست هذه مكونة من 4 أشياء. The probability of the set is the probability of the first one plus the probability of the second one plus the probability. لأنه إيش؟ كل واحد منهم mutually exclusive من الثاني. They cannot happen at the same time. You cannot have 1 1 and 2 1 at the same time. So بس عشان we remove the confusion. الكما هذه is within parentheses of a set. So this is not an and. تمام. الكما هنا is separating items in the set. عشان كده we add the probabilities. بينما هنا الكما is an and. So this is an and. The and translates into intersection. واضح الفرق؟ تمام لأنه مهم جدا ما تلخبطوا فيها. طيب. I think time is up ولا؟ طيب, I think time is up. Thank you very much, Shiva. Next time, inshallah, we'll continue with the details of the. Have a nice long weekend.